Again, this is adding, subtracting polynomials, which is the same thing as combining like terms. A reminder that like terms, they have the same exponent and same variable. Okay, so A, 10x plus 12x, I just view this as how many x's do I have? Okay, if I've got 10 and I add 12 more, I've got 22. It does not change the variable itself. Okay, especially now that we've dealt with exponents, a lot of students will say, oh, yeah, that's 10 plus 12, that's 22, and then x plus x is x squared. Remember that how you change the exponent is by multiplication, right? X times x, that's x squared, right? And I get that by, again, adding the exponents, okay? A property we just kind of worked on in our other opening set of problems, right? So that's really all we're doing, okay? Finding like terms, adding them together. So part B, I can only add x's with other x's. So negative 2x and 9x is 7x. I can't combine that 6 with the x's, so I just add it on to the 7x at the end here. Part C, and you'll see once I get multiple terms, I kind of mark them in different ways just so I have an idea. It helps my eyes say, oh, I need to add that x squared with this 3x squared, which is 4x squared. Then I circle all my x's, 4x and 7x, that's 11x. And then this 1 can't combine with anything. Okay, so x squared is different than x because the variable, or excuse me, the exponent is different. Yeah, question? When or why am I not? I'm not adding the exponents because we only add exponents when we multiply the bases, right? We're not multiplying anything here. We are adding, right, which is very different than what we did before, right? Okay, so again, if I had like x cubed times x squared, that's x to the 5th. But if I had x cubed plus x squared, I can't combine those. Okay, those are different terms because of the exponents being different. So it's a different operation. Okay, 1 sec. All right. So I basically just said these things, but again, based on how earlier went, we need to be checking notes, especially when we work through homework. Okay, when we get stuck. In fact, the best practice when you are working through homework is do that homework. If I get confused, check notes first. If I can't figure it out from the notes, that's when the answer key can start to become helpful. But you should be checking notes before you go straight to that answer key. Okay, so back to, again, like terms. Okay, so we're really just combining like terms. Again, they need to have the same variable and the same power or same exponent. Be sure to pay attention to your signs, so adding, subtracting. And then common practice is to write the final answer in descending order of exponents. Okay, is what that should say. So meaning the term with the highest exponent gets written first, term with the second highest exponent gets written second, and so forth. That's not wrong if you don't do that. It's just, again, more common practice, okay, but not mathematically incorrect. All right, well, let's look at a couple problems here. Again, we're not going to do all of these. But when we have parentheses, the first thing we need to figure out is, do the parentheses matter? Parentheses really only matter if we need to multiply anything. There's no number outside of this parentheses, so I have nothing to distribute. So the parentheses do not matter in these first 3 terms. Then I'm adding the next 3 terms. And so again, it's really like I'm distributing a positive 1. And multiplying by positive 1 doesn't change any of those values. So in this case, the parentheses don't matter. So I'm going to add my x squared, so 5x squared and 9x squared. That's 14x squared. Negative 3x and 2x is negative x. And then 7. That's another way I can mark these with dashed lines. 7 plus 7 is 14. Oops. And this is what I mean by writing the terms in descending order of exponent. So we have x squared first, followed by just the x to the power of 1. Right, that was another thing that threw a lot of us off, that when we don't see the exponent of 1, some of you are thinking it was a 0. We had kind of ideas all over the place with that. And then 14. Okay, so the number gets written last. All right, now 2, again, when we start thinking about do the parentheses matter, again, the first set of parentheses, I have nothing that I'm distributing, so they don't matter here. But in the second set of parentheses, I'm subtracting those terms. So one way to read this is y cubed minus 4y squared minus 2 minus or negative 1 times all those terms. So we're essentially distributing a negative. And I'm going to always recommend that we distribute that negative and rewrite everything. Okay, so the first terms don't change. I'm just going to write them down exactly as I see it. The next three terms, all the signs are going to change because I'm multiplying them by a negative 1. Yeah, go ahead. We're not multiplying bases, right? This is different than the exponent properties. Okay, this is negative 1 times those terms. The only time you would distribute to an exponent is if you had x cubed to the power of 2. So an exponent raised to an exponent. Okay, but yeah, exponents don't change when we're just simply combining like terms. All right, so y cubed, I have 1 and I have negative 6 of them. 1 minus 6 is negative 5y cubed. Then I have 4y squared. And sorry, that's a negative 4y squared. And positive 6y squared, that's positive 2y squared. And the minus 2 minus 4 is negative 6. Bless you. All right, we'll skip 3. I want to do 4, and then we'll pick like 2 or 3 on the back for us to work through. And we'll call that good because, yeah, not much is going to change. Okay, but number 4 is odd because now I have other variables. We have x's times y's, and we even have like x squareds times y's. Okay, so again, when we think about how we can combine or what we can combine, they need to be the exact same term, meaning I can add xy with other xy's. I can't add an x times a y with an x squared y because that exponent is different. Okay, so the combining in this last problem is going to be a little bit trickier with that second variable being present. First thing, I'm going to distribute the negative and rewrite everything. So I get xy minus 7x to the 4th plus 8x squared y. And then this is minus 6x squared y. And then plus 4x to the 4th y squared. And then minus 7x to the 4th. Now, when we think about the order in which we should write these, like that descending order, it's a little bit trickier to really have like a common practice with this because sometimes the x has a bigger variable or exponent, sometimes the y has a bigger exponent. So it doesn't really matter the order in which we write these after we combine them. So let's just kind of go in the order that we're seeing them. So I have xy. Are there any other xy's? I don't think so. Right? All the other xy's have exponents. So we just have an xy. I have a negative 7x to the 4th. I have another negative 7x to the 4th. And that is it. So negative 7 minus 7 is negative 14 x to the 4th. Then I have an x squared y, so I have 8x squared y. I'm going to subtract 6x squared y from that to get 2x squared y. And then the only other thing I have not dealt with is this x 4th y squared. We don't have any other x to the 4th y squareds. So it's just plus 4x to the 4th y squared. All right, and that's basically it. Okay, so after you're done writing this down, go ahead and flip the page over. And we'll find like maybe 2 or 3 for us to work through. Again, we don't need to do all these. But what you're going to see on the back side, there just might be more grouped together. We have like 3 different things. So like let's do 7. We can skip 5 and 6. I like 7. Because again, with 7, you need to decide, do these parentheses matter? Then does the second set of parentheses matter? And does the third set of parentheses matter? And again, how do we deal with that negative? So let's do 7, and then let's do 7 and 8. Okay, we'll skip 5, 6, and 9. So 7 and 8. Okay, do your very best with them. We'll check those, and then we'll get going on homework shortly after. homework check-in. Again, we didn't get a lot of time since that first activity took a little longer. All right, so number 7, there ends up being a lot of terms, right? And it gets not hard, but it's so much little details that it is easy to mess up the addition or subtraction just because there's so many different terms and we've got to be really careful, especially with the signs. Okay, so the 4x to the 4th. There aren't any other x to the 4th, so there's nothing to combine that with. My x cubes I circled. There was only one x cube, or one term that had x cubed. There's 3 of them, so 3x cubes. Then my x squareds, I put dotted lines underneath those. So I see -9 plus 8 is -1. Minus 5 gets me to -6x squared. Then I put triangles underneath all the x's. 8x minus 3x is 5x. 5x minus 9x gets me to -4x. And then the numbers, I tried to do a different marking. Those are kind of like just little slashes. So -7 plus 8 gets me to a +1. Right? So easy to make mistakes on that just because there's so many different terms. But I'm always going to recommend that we distribute the negative and then rewrite everything. And any questions with how I'm getting any of those terms there? Yeah, Melvin. What's that? Add the 1? Which one? Oh, so that should be +2 at the end? There we go. Now we're correcting Mr. Younger, and I forgot this +1 right here. Change that to +2. Good call. All right. Anything else? Are any other mistakes I might have made? Like I said, it's easy to make mistakes. It's going to happen. All right, last one. Again, we can only combine them if both variables have the exact same exponents. So first, I see a 4m squared, n squared. I can combine that with another 2m squared, n squared. So 4 plus 2 gives me 6m squared, n squareds. Then m to the 4th, n squared. I see -3 right here. But then I'm adding 5. -3 plus 5 gets me to 2m to the 4th, n squareds. Then -7n minus 5n is -12n. Questions there? Okay.